Consider the region bounded by the curves y equals 3 root x and g of x equals 3x below. So I got a nice little graph there of those. We know this one is the 3 root x, and the other one must be the 3x because it's a straight line, right? Linear equation. Okay, they want us to find the volume, revolving it around the line y equals 6. So that's a little tricky. Down here, I'm showing it on the 3D calculator thing. Here it is, up at y equals 6. We're going to rotate that up there. Here's what it looks like in 3 dimensions. Y equals 6 line, rotate it. We're going to make this frisbee kind of thing. I'm just showing half the rotation there so you can see the edges of the discs. Down here, I actually drew more of the picture and I extended it. This is the line y equals 6, so we're going to rotate it up this way, right? We're rotating about that line right there. So everything's going to flip up to there. Okay, so that's what we're talking about. We see it in 3 dimensions. How are we going to find the volume? Well, you know volume of each washer. Every washer is pi capital R squared minus pi little r squared times the thickness. And in this case, the thickness is going to be dx times the thickness because we are stacking them up, as you can see. See a little thickness here, dx on the x-axis. Okay, so back to the problem. So the whole question is, what is the outer radius and what is the inner radius of each of those washers? Well, you can see right here from the washers on this diagram most specifically, or maybe I should even just do this one. Yeah. How about this one? The one that's blown up. Okay. So we have here the outer radius. It goes from here to there. That's the capital R. And then we have here the inner radius that just goes from there to there, the little inner radius. So the little inner radius, I guess I got the colors backwards, whatever. The little inner radius is the one that hits this curve here. And this curve is the y equals 3 root x, isn't it? Yeah, 3 root x. And the other one's 3, the straight line is 3x. This one is y equals 3x. Okay, so how are we going to find then that radius? Well, remember that all the way from top to bottom is clearly 6. Just look at the diagram. Okay, so then, and you might be, well, we got to remember that a y value is up to there. So that part is actually y equals 3x up to there, because that goes to the straight line. And let me go back to the y equals 3 root x. Up to there, that's the y equals 3 root x, because a y value, think about graphing. Whenever you graph something, if you want to get to, say, this point, you go over x, up y, starting from the origin, huh? Not starting from up here or somewhere else. Starting from the origin, this is over x, up y. Any point on a graph starts from the origin. It's over x, it's up y. So in other words, this point on the line y equals 3x is up from the origin. And this point on the other y equals 3 root x graph is again up from the origin. So therefore, if we want to find, for example, little r, we got to take the whole 6 and take away that y equals 3 root x. So it's going to be 6 minus 3 root x. And if we want to find the capital R, right here, I'll write it over here. Capital R is going to equal, what's capital? The whole distance is 6, and then up to here is 3x. So it's going to be 6 minus 3x, isn't it? Do you see that? Again, the capital R goes all the way to here. How do you find that? Take the whole 6, take away 3x. because y is from the origin up. And then the little r, which is there, is the whole 6, take away the 3 root x, because that's the y value up to the curve graph. So there we go. We've got the inner and outer radius. Now we can do the integral. It's going to be the integral of pi capital R squared minus pi little r squared dx. I'm going to put the pi in the front. Integral is going to go from 0 to 1 because it goes from here to here on the x-axis. And the capital R, we know, is right here, 6 minus 3x squared minus, and then the little r is right here, 6 minus 3 root x, whole thing squared, dx. There we go. That'll give us the volume, and that's exactly what they got. And so there we go.